repository. We will review the data repository implementation process. We will be covering the data repository application itself, such as how to navigate to it and what you can expect to see within the data repository application. We will then review supplemental documentation. And we will review monitoring and usage of the data repository. Lastly, we will wrap up today's presentation with a question and answer session. As previously stated, feel free to post any questions you may have throughout the presentation into the Q&A chat window, and I will address them during all Q&A sessions. So what is Meditech's data repository? It is essentially a copy of the Meditech transactional environment in a SQL format. The data in the data repository is stored in a data warehouse on the SQL server. This warehouse provides for detailed analysis of data across the entire organization by utilizing customer-defined reports. Meditech's data repository promotes the following. It allows for a separation of resources. With all of this data living on your SQL server, housing and reporting off of it on one dedicated server allows for a separation of resources. Within the Meditech HCIS, data resides on several machines, file servers, segments, etc., all across the Meditech network. As a result, reporting out of Meditech can be affected by a number of different variables, which include users running compiled reports in Meditech applications, and users running NPR report write reports, as well as end user activity on the machines themselves. The data in SQL lives on a separate dedicated server, and furthermore, queries on this data also run on this separate machine, which allows for better overall reporting efficiency. It allows for a combination of data within a number of areas. If you are migrating to the 6x61 platform from an existing platform, then you will most likely be keeping your historical database around. Using SQL, you are able to write reports and join data between your historical Magic or client-server database to your new 6x61 databases. Your SQL Server may also be used to house non-Meditech databases. For example, maybe your organization is using a third-party billing or OR system. Well, with the data repository, you are now able to combine both Meditech and non-Meditech data in one data warehouse. This data can populate separate tables within the same databases, or this data could also populate separate databases on the same SQL server. The data repository is also the primary resource for combining data from NPR applications with data from the newly coded MAT applications. This allows for easy reporting between the two environments within the 6x61 platform. The data repository can be used for long-term decision support. The reason for this is that data from your SQL server is never purged and should be available forever because the data in your SQL environment is not tied to any Meditech purge parameters. This also ties into the separation of resources due to the fact that the SQL Server is a dedicated machine that isn't impacted and does not impact any of the Meditech applications. Storage can simply be added to accommodate data growth. This means that the Meditech data repository allows for data analysis across large populations of patients and providers for as long as you have been sending data to SQL. All of the previously mentioned benefits allow for flexible reporting. Users are able to generate reports from data that is housed within multiple databases, MISs, or from any additional vendors that set up SQL databases. You are not restricted to reporting purely out of SQL as well. You can use any off-the-shelf products such as Microsoft Access, Crystal Reports, Metasolv, or even SQL itself. The only caveat to this is that the tool that is chosen to be used for reporting needs to be ODBC, or Open Database Connectivity compliant. While having an understanding of the Meditech structures themselves is helpful, it is not required. There are tools available within Meditech, as well as SQL, to assist you in transitioning from NPR reporting to SQL reporting, or to just get an understanding of the SQL data scheme. I will be covering these tools and utilities throughout the presentation. Now let's take a look on how data gets from Meditech to SQL. To start, we will review the data repository transfer process for the NPR side of the 6x61 platform. Envision an end user sitting at their workstation. They file an entry, maybe a patient admission or discharge, an edit to a patient bill, or a dictionary edit, whatever it may be. When this data is filed, the application filer programs file the edit to the application databases within Meditech. Within those application filer programs, we have what we call data repository hooks. Once the data is filed, the data repository hooks will be called to place that data on the data repository activity index. Each application is set up to send to the data repository and will have a location on the activity index. For example, MIS will have an MIS location on the activity index, MRI will have an MRI location, and so on. Once the data has been placed onto the activity index, the data repository transfer jobs come into play. The transfer jobs, which run continuously 24/7, cycle through the activity index and pick up that data and deliver it directly to your SQL database. These transfer jobs can encompass an entire group of applications or a single application, as well as a group of tables or a single table, depending on your reporting needs. Once the data resides in the SQL tables, any third-party reporting tool can be used to report off of the data. This transfer method is under the Meditech ODBC transfer process. Previously, DR Manager was used to insert the data into SQL, but we found there were some limitations with that, so the Meditech ODBC transfer method was introduced. If you are a migrating site, you may see the DR Manager application on your SQL server, but it is no longer used in the 6x61 platform. So now we know how the transfer process takes care of your daily entries and edits of data. But there are other ways of bringing data over to SQL that bypass the transfer process. The first method is called an initial load, or IL for short. An IL essentially goes into the Meditech structure and extracts the historical data and delivers it directly to your SQL databases. An initial load is run anytime a new table is created or a new application is enabled to feed DR. We also run full module ILs during the implementation process after everything is set up and configured. The second method is called a conversion initial load, or CIL. You can think of these as targeted ILs. Let's say, for example, you have an update and there is a newly created column in the ADM visits table that needs to be populated. We would run a CIL to populate this new column rather than running a full initial load for the entire table. Lastly, we have the Special Initial Load, or SIL. This is a customer-facing initial load utility allowing you to run your own initial loads. Maybe you want to ensure that tables in your report are up to date, or the grouper list was updated and tables need to be repopulated. This allows you to run the IL yourself without having to go through the hassle of opening a task, getting change control, and then waiting for your specialist to go in and start the SIL. You can now go in and kick one off right away. One thing to note is that the data repository is only capable of sending data one way. We can only grab the data from Meditech and insert it into SQL, but we cannot take the data out of SQL and send it back to Meditech. The MAT transfer functionality is very similar to NPR. Again, envision the end user sitting at their workstation. They file an entry which begins the transfer process. When this data is filed, the application filer programs, the application filer programs file the edit to an MIS audit log where all views and edits are stored by MIS. Once the data is in the MIS audit log, the data repository audit jobs are activated to copy the edits and additions from the log. The last step is for the DR activity job to deliver the new records and/or edits to SQL. The ultimate difference between the NPR functionality and the MAT functionality for DR is the use of two sets of jobs for DR instead of one. The activity index from NPR is not needed in MAT. Instead, the DR audit jobs pull the Meditech edits or writes and place them in a queue, which is then picked up by the activity job. The activity jobs will determine how many workers are needed to deliver the data to SQL. Split up the work by application and tables, then deliver the data to SQL. And just like in the NPR environment, MAT-DR also uses initial loads, special initial loads, and conversion initial loads to refresh tables as needed. Now, let's take a look at how data gets from your end user to SQL under the transaction server transfer method. To start, I'm going to explain what this transfer method actually is. Transaction server capture, or TSC for short, is DR's newest method of data transfer for the MAT platform, which uses the transaction servers to obtain its data. By doing so, numerous steps in the transfer process are eliminated, making TSC an optimal and more efficient method of sending data to the SQL Server. Now let's review how data is going to get to SQL. When data is entered or edited by an end user, the filing process begins. In the MAT platform, all applications are designed to log transactions of edited data on the transaction servers. Through the utilization of the transaction server capture method, DR worker jobs continuously scan the transaction logs, picking up any and all edits to then commit them into SQL via a DR Manager or Meditech ODBC connection. By doing so, less steps and resources are used to improve the overall transfer process of data to SQL. This new and improved capture method is currently in the early adopter phase, and once in general release, all data repository customers will be changed from MIS audit capture to transaction server capture. Now that we have discussed what the DR is and how data gets from your end users to SQL under the different transfer methods, I am going to do a quick review of an NPR versus MAT comparison in regards to SQL. The MAT metatext structure is going to be a one-to-one comparison in regards to the tables. As displayed, data in metatext is stored within an object and a record. For example, the object himrec and the record main make up the metatext structure himrec.main. While in SQL, the corresponding table is called himrec_main. The fields within metatext are the individual pieces of data such as a patient's name or address, and each metatext field will equate to a corresponding column within SQL. As the metatext structure stores its data in a hierarchy, SQL is going to follow that same format as well, with the main record being the parent table to the other tables within an object. In NPR, the metatext structure uses DPMs and segments to store its information. While a DPM and segment does not match up to the exact table name like an MAT, there are tools available in both within SQL and the DR application to help identify which table or tables a DPM and segment sends its data to in SQL. The individual fields within metatext are referred to as elements, and each element is going to correspond to a column within SQL. Again, NPR follows the hierarchical structure design, and the tables within SQL reflect this as well, where tables associated to a main segment will be the parent table to tables associated with segments below the main segment. Now, let's take a look at the data repository implementation process from getting your test environment up and running to what happens after live has been set up and populated.
This video is going to run through the new
The first step of the data repository implementation process is to review and ensure that the configuration of the DR background job machines and SQL Server match the hardware proposal. Keep in mind that these are minimum hardware recommendations, so depending on the overall usage of the DR SQL Server, additional resources should be considered. Following confirmation of the hardware setup, we proceed with setting up the test environment. The code deliveries group will deliver the DR code to your test environment, allowing us to access the DR databases within your system. Once the code is in place, the DR programmer goes in and sets up the DR environment and sends the table scripts and schema for your release to the SQL databases that were created to house your data. Once the environment is prepared and the table schema is in place, your DR implementation specialist will go in, configure your parameters, set up the DR jobs to run on the defined background job machines, start up the DR transfers, and lastly, run full module initial loads to load all of your data from your test environment into SQL. After the loads have finished, we will hand over the test system to you all to begin entering data, ensuring it flows over to SQL, writing and testing out your SQL reports, as well as monitoring the data repository on a daily basis. Essentially, the same steps that took place for the test setup will occur for the live setup with some minor differences. Instead of the DR code being delivered separately from the other applications, all code for all applications is moved to live at the same time. This is typically taken care of a month or two before the specified go-live date. Approximately 1 month before the go-live date, your DR implementation specialist will request live change control to set up and get the live DR environment ready for the go live date. Once change control has been provided, the DR programmer will again deliver the table, scripts, and schema to your live databases and configure the live DR environment. Once the programmer is done with their steps, your DR implementation specialist will configure the parameters and set up the jobs to run on the defined background job machines. On the defined go live date, your DR implementation specialist will log in, turn on data repository capture, start the DR transfers, and start the full module initial loads. Just like in test, once the live loads are done and the system as a whole looks good, it is handed over to you all to continue to monitor and maintain. Before that is done, we evaluate the live system more thoroughly. We will ensure that your transfer jobs are not falling behind and the initial transfer configuration keeps the transfers up to date. We will review the impact of the data repository on the defined background job machine. If resources are low on that machine, we may scale back on the number of jobs that we can run at once or request additional resources be added to the machine. We will review the system for any major systematic errors. By systematic errors, we mean errors that will impact the data repository or Meditech system negatively. Once we have determined that the data repository looks good and everything is loaded, it will be handed off to you to continue monitoring and maintaining the data repository on a daily basis. What should be done will be covered later on during the monitoring and usage portion of the presentation. We will now be going into the data repository application overview portion of today's presentation. For the application overview, we will be covering the following topics. How do you navigate to the DR menus, both MAT and NPR? Review the transfer jobs and how to monitor them. We will be covering the customer-facing utilities that will assist you in maintaining and optimizing your DR system. We will go over the DR error logs and what to focus on. We will be going over the individual screens within the DR parameters and what some of the values mean and stand for. Lastly, we will review the routines that are available to help locate and understand the data and tables within SQL. To begin, I'm going to cover how you actually navigate to the data repository menus. I am going to point out where both the NPR and MAT data repository menus can be found, but I will start with the review of the NPR data repository. For the sake of this presentation, we will be using one of our in-house training rings. You may see some minor differences between this presentation and your own facilities ring, but functionality-wise, what is available should be the same. First, open up whichever client or environment you are looking to access, whether it be for your test or live environment. From there, you will want to go into the Info Systems option. Once there, you will see both menu options for the data repository. Data Repository MAT, and Data Repository NPR. We are going to start with reviewing the NPR side of the data repository. From the Info Systems option, you just click on the Data Repository NPR option and you will be brought to the DR main menu. Almost all options shown here are available within the Operations desktop, where we will be going next. After we review what is available within the Operations desktop, I will loop back around to the main menu and review the few options that are only available here, but not in the Operations desktop. As soon as you enter the Operations desktop, you will be brought to the Monitor tab. This tab gives you a snapshot of the master background job or engine for the data repository. In addition to that, you can also get a glance of file maintenance. You want to ensure that the master background job is running and reflects a current date and time within the status field. If you see that is not running or has an older date and time, then try stopping and starting the job via the Stop Start button at the bottom of the screen to see if that will get it running. If that does not work, then please reach out to your data repository specialist for further review. It is also important that file maintenance runs on a daily basis to clear out all of the statistical information that the data repository compiles. This statistical data is stored on the file servers themselves. If file maintenance is not consistently running, then you could see a negative space impact on your file servers. The next tab is the Data Transfers tab. This screen displays the status of your data repository transfer jobs. In Live, you will see a transfer job for each Meditech application that feeds data to the data repository listed here. While in Test, you may only see one HCIS level transfer job. The reason for this is that test data is minimal and can continue to function without a large impact with only one transfer job. While in Live, we want to get the data over to SQL as quickly as possible. So each application is given a transfer job. Just like with the master background job, you want to review that all of your transfers listed here are running and reflect a current date and time in the status of the job. If they are not, then reach out to your data repository specialist for further review. Within this screen, there are two other options that I would like to review as well. Those are the Pending Activity button at the bottom and the Schedule tab at the top. The first one I am going to review is the Pending Activity option. This loads how many rows are waiting to be sent to SQL on an application and table level. You are able to load the pending activity via all applications as shown on the screen, or specific applications that you decide you want to see. We recommend loading pending activity for all applications daily so that you have a good understanding of what normal levels of activity are and can identify when there is too much activity, which could point to a larger issue. Just keep in mind that a mass refile done within an application will cause large amounts of pending activity. Next is the Schedule tab, which is located at the top of the data transfer screen. This will allow you to put in continuous downtime schedules. This is one way to stop your jobs with a planned downtime, but is really only beneficial if you plan to continue with the defined downtime schedule. For example, if you plan to have a downtime occur every Wednesday from 1 a.m. to 2 a.m., then I would recommend making use of this routine. You just need to click on the Edit Downtime Schedule button, then define the days of the week and times in which you want the DR jobs to be halted. We recommend placing a 30-minute buffer on each end to ensure the jobs stop in time and to ensure that jobs start up well after your downtime is over. You don't want the jobs running when you start your downtime or trying to start before it's over. The next screen is the initial load screen, or IL for short. If you remember back to the diagram, the initial load is a tool that we use here at Meditech to load historical data from a Meditech structure into SQL. We run ILs by the application themselves, but through manipulation of the parameters, we are able to determine what tables will or will not be included in the initial load. The initial load screen will provide a historical snapshot of the last time an initial load was run against that application, or if there are any initial loads currently running. If you are planning on having DR downtime, then you can manually stop any running ILs and restart them once you are done via the buttons located at the bottom of the initial load screen. Next, we have the special initial loads routine, or SIL for short. This is the customer-facing initial load routine that you are all able to access and make use of. When you are first brought to the screen, you will see any running special initial loads or completed ones. If the completed ones are bogging down your screen, you can just click the Hide Completed button at the bottom of the screen to hide those from view. If you ran an SIL and would like to continue running that without having to set up a new one each time, you can click on the Save as Template button, give it a name, and then add it to the SIL template dictionary. So let's take a look at how to actually set up and run your own special initial loads. To start, just click the New button located at the bottom of the screen. If you created a template or saved an existing SIL, you could simply hit F9 in the template field to pull up a dictionary of any saved templates. If you pull in an existing template, you would just need to click Start and be on your way. If you are not pulling in a template, then you would just start filling out the fields shown. Give your SIL a name. You will want to name it something intuitive so you know what it is included on first glance. You would then choose the application for the table you want to start the SIL and then define the DPM for that table. Both the application and DPM fields will prompt you asking if you would like to include all tables from the application or DPM chosen. If you are just running your SIL against a table or subset of tables, you will want to say no, otherwise it will turn on and populate all tables. Lastly, just add the table or tables that you are looking to run the SIL against to the table section and click Start. Next, we have the validation routine. This will allow you to compare what data is stored in Meditech against its corresponding SQL table to ensure that everything is present within SQL. Via the Meditech validation tool, you are able to ensure that the priority tables used in reporting for your organization are accurate and up to date. This provides peace of mind and confidence within your end users, knowing that these tables reflect the correct data. As you can see, there are multiple options within this routine. You have the Enter Edit Reports option, which is where you create your validation template. Then you have the Enter Edit Schedules option, which is where you define when and how often you want your validation to run. Next is the Process Jobs option, which is where you monitor your running validations. Lastly, there is the View Results option, which is where you check to see if there were any discrepancies and what those discrepancies actually are. The last two options are just dictionary views of the Enter Edit Reports and schedules options. I will now walk you through the process of how to set up your own validations by starting with the Enter Edit Reports option. This screen is where you create your validation template, such as what it is called, how much of the data you are going to cover, as well as the table or tables you are validating. Starting at the top, there is the mnemonic field. If you created a validation previously or would like to create a new one, this is where you would start by giving your validation a mnemonic. Next, we have the active field, which simply determines whether or not file maintenance will remove your template. In the name field, you can elaborate on your mnemonic further. This is almost a description field. The sample size, number to check in sample, and approximate validation coverage all fit together. The sample size determines how big of a sample the job will grab, and then the number to check in sample is how many records will be checked within the sample, creating the overall approximate validation coverage. For smaller tables, we recommend doing 1,000 and 1,000 for the sample size and number to check in sample, overall equating to 100% validation coverage. For larger tables, we recommend going with something equal to 50% coverage. For the job class, you are always going to want to set it to validation. This way, if you set up a dedicated background job machine for validation, then the jobs will run on that machine. The include categories are where you define what you want to validate. You can validate an entire application, an entire DPM, a table, or a subset of tables. Only one of these fields should be populated. Otherwise, the validation will run against the category that covers more data. So if you define a DPM and a table, then the validation will validate the DPM and the table. Once you have filled this out, click Save and move on to the Enter Edit Schedules routine. The Enter Edit Schedules routine is where you define when you want your validation or validations to run and if you want it to be a recurring theme. The first thing you do is select a date for when you want your validation to start. Maybe you want to run it later on in the week, a weekend, or a holiday, whatever it may be. Then you pull in the validation or validations that you created in the Enter Edit Reports routine. You will pull in one report at a time and define the rest of the fields shown before adding another report on the same day. After you pulled in the validation that you created, just select the start time for the validation and then the recur frequency, so whether or not you want the validation to run one time, weekly, or monthly. Next, you choose the issues to report. Generally, you will want to report all issues, but if you are only concerned with missing rows or column mismatches, then you are certainly able to report just those issues. Next is the Max Expand Workers category. This just allows you to define how many workers you want to help process the data. The default is 3 workers, so if you plan to increase the number of workers from 3, then we recommend reviewing the background job machine where the jobs will be running to ensure that it isn't pegged at 100% CPU. Just like in the Enter Edit Reports routine, the job class will be validations. Lastly, there is the database category where if you have multiple application databases, and you do not want to validate the data in all of those, you can select which one or ones you want the validation to run against. Next, we move on to the process jobs routine. After you create your validation report and set your schedule, you will want to go to the process jobs routine to review any running validations or to check to see if the validations have completed. This screen will show the status of any running or completed validations, as well as provide some supplemental information. In addition to that, you can change the number of expander workers on the fly by clicking the Change EWs button at the bottom and changing the number to however many workers you want processing the data. One thing to make note of is that if you stop an NPR validation while it is running, it will not restart from where it left off, but will need to be started from the beginning. Since the comparison is done within SQL in a temporary table, there is no way for us to know where the validation last left off since the sample is different every time. Just keep that in mind when planning downtime. Once your validation has finished, you will move on to the View Results routine to actually view the results of your validation. Once you enter the View Results routine, you can press the F9 key to pull up the dictionary of finished validations. From there, just select the validation you want to review and then put a Y for the tables with issues field. Otherwise, it will display tables that had no issues along with tables that did have issues. Once you have loaded your results, if a table has discrepant columns like ADM Visits does in this screenshot, you will have a plus/minus sign next to the table name. This will allow you to expand out and collapse which columns have discrepancies as shown. If you want to see what records are missing from the table, then just click the green circle with the arrow next to the numbers highlighted in red. This will pop out another window showing you the specific records themselves, including their primary keys. At the bottom of the page, you will see a Recheck Issues button. This double-checks the validation results to ensure that the records reported as missing are truly missing and were not sent over to SQL while the validation was running. It just ensures that there are no discrepancies as a result of timing. Now, let's take a look at the different error routines located within the data repository, starting with the All Errors routine. The DR error log can be daunting for a first-time user due to the fact that we are capturing data from your entire Meditech system, and we are the front line for data integrity. The DR error log is very similar to an event log, and not everything shown is necessarily an issue. So, before venturing into your DR error log, we highly recommend building a list of tables used by your organization in your reports or priority reporting tables so that you know what to look for. From there, you can select the application you would like to review or set of applications, and then click on the Summary button to load the errors from those applications. If you would like to filter your results beforehand, you can fill out any of the fields located towards the bottom of the screen to limit what will be displayed. The one type of error that should be reported to us, no matter the table, would be a skipped sequence or sequence out of sync errors. These error types will prevent that table from updating until it has been corrected, so it is important to check for those and have them fixed as soon as possible. Should you have any further questions in regards to any errors seen, then feel free to reach out to your DR specialist for further clarification. Once your summary has loaded, you will see all errors for the application or applications you selected or any errors that fit the criteria you set on the previous screen. From here, you can evaluate the errors and look for errors that are occurring for tables that are in your priority table list. Once you find an error that you want to take a closer look at, just select it and click on the Detail button. So you have now found an error for a table that you want your DR specialist to review. When you open up a task with the DR to have this error reviewed, just put your release, the table name, and as much of the error message as possible into the description. Within the text portion of the task, you can provide everything else or just attach a screenshot of this error so that we can review further. Next, we have the exceptions routine. While the error log pertains to system errors and errors when inserting rows into SQL, exceptions deal exclusively with specific columns and fields. For example, a value is trying to be inserted into SQL that is 20 characters long when the column in SQL only accepts a length of 10. The last 10 characters of that value are going to be truncated in SQL, and an exception is going to be filed to the exception log. As the screenshot shows, this screen is nearly identical to the error log screen, so functionality-wise, they're both going to work the same way. The same concept of priority reporting tables applies here when reviewing this log, and even more so, the specific columns you are using within those tables. If you are running reports and find that certain pieces of data are missing, truncated, or appear to be incorrect, then you should review the exception log to see if there are any issues with specific columns. The last error utility within the DR are the database logs. These are direct SQL insertion errors that are caught by DR Manager. Most of you will be using the Meditech ODBC transfer method and not DR Manager, so you will most likely find that there are no files here because of this. If you are using DR Manager and cannot find any errors for why a record is missing from SQL, then looking here would be your last stop. You would just press F9, select the file that has a timestamp from when you think the error should have come over to SQL, and then the file will pull up any results that it has. Once within that file, you can use the buttons at the bottom of the screen to filter the results. If you see a table that you're having issue with appears here, just view the details and open up a DR task providing those details so that we may further review. Now we have the test service. This is a tool that ensures that the connection between Meditech and SQL is secure and functioning. This is something primarily used during the implementation process or after an update to make sure all the necessary components are in place. However, the test service is a good place to begin troubleshooting. This would let you know where the disconnect is between Meditech and SQL, such as if a SQL service is down. Next is the ODBC setup check, which performs a similar function to the test service that we just covered, except this applies to the ODBC transfer setup. This will ensure that the necessary ODBC components are in place and that we can communicate directly with SQL instead of through DR Manager. These components are the Microsoft ODBC driver or SQL native client, as well as whether or not the user defined to run the job has sufficient permissions within SQL. The next tab is the Purging tab, which is interchangeable with File Maintenance that we saw earlier on. This screen is just a general overview of File Maintenance as a whole. As you can see, it will show file maintenance of the server, as well as each individual application. The snapshot back on the Monitor tab will let you know the overall status of file maintenance, while this goes into greater detail. This screen will show all the parameters that are defined during the DR implementation. A detailed field-by-field description of these parameters is available on our product resource page. So I'm going to highlight the major areas of focus in this dictionary. The general screen is the first screen you see when viewing parameters. This contains basic information such as the server name, database name, and path where the DR SQL scripts are kept. The Transfer tab is where you'll find transfer settings for the HCIS, such as whether the table groups can be created, which we'll discuss more in a few minutes. The Database tab specifies what Meditech applications are enabled for data repository, as well as the file maintenance parameters. The source ID that's specified here helps organize the data in your tables. For example, if you have several ADM databases. The Tables tab allows you to quickly see whether a table is on, off, or has a file maintenance override. You can also see whether newly created tables will be turned on or off by default. Next, we have the Dictionaries tab. This is where you can go to view any application groups, table groups, or special initial loads that were created. You can also create table groups and special initial load templates here. Next, I am going to cover the Enter Edit Table Groups option, for table groups are beneficial in increasing the frequency of updates to your priority reporting tables. Within the Enter Edit Table Groups routine, you can create and manage table groups. Since all tables are going to have their data processed and sent to SQL by the individual application transfer job, you may find that you want certain tables to update within SQL more frequently. This routine allows you to split tables off from their main transfer job onto their own transfer job, increasing their processing time and the amount of time it takes to update SQL. Once in the routine, you will first want to name your group. This is what will appear in the Data Transfers tab, so you will want to name it intuitively so you have a general idea of what tables are a part of that group. The active field will be set to Y, otherwise the transfer group will not be created. The name field is a chance to describe what your table group is, and the type will default to user since it was a user that created the group. You will then select the application of the table or tables that will be a part of the table group you are creating, and then decide if you want to limit it to a specific application database. This will only matter if you have multiple application databases. Otherwise, you will only have one option to choose from. The transfer type will always be continuous to match the other transfer jobs, and the job class will be Table GRP for the table group process. After that, you will start plugging in the tables that you want to be a part of the table group and then click Save. You can then go to the Data Transfers tab and see your newly created table group. Following the Dictionaries tab, there is the Tables tab. This is another dictionary where you can view tables based on certain sets of criteria. You are able to view all the NPR information and columns associated to a table from this screen. If you want to see what NPR field feeds which table or tables in SQL, you can do that by using the NPR field option. If you want to see all tables associated to a DPM or an application, then you can make use of those fields as well here. We also have two tables in SQL that perform these same functions, so you can either make use of it here or within the DR application or within SQL, which I will be going over later on. Next is the build query routine, which is very helpful for sites that were and are heavy NPR report users. The report field is a dictionary lookup to all of your NPR reports that you have created. This routine will take any of those reports and turn them into very basic SQL queries by translating the NPR information into SQL tables and columns. Depending on the complexity of the NPR report, some tailoring of the query will be needed to get it to run in SQL and return results. The next two tabs go hand in hand with each other, so I'm going to cover the second one first and then cover the one before it. Those are the compare and export schema routines. Starting with the compare schema routine, this routine will allow you to prepare well ahead of time for an upcoming update. From the DR Product and Resources homepage, you can download the database schema for a future release, import it into this routine, and see what the changes are between your current release and the release you will be going to in the future. The file from the Product and Resources homepage will contain the table schemas for both NPR and MAT, so you will want to be sure to use the NPR XML file for the NPR side. When you first come into this routine, you will see what is shown on the screen. The first thing you will do is click on the Import Schema button at the bottom of the page. Navigate to where the schema you want to load is located within the Windows Explorer, and that will populate the future field located in the Select Release to Compare section. After you have pulled in the schema, you can begin selecting the criteria that you want to review. Starting at the top, You can select any number of applications you want to review the changes for. Maybe your reports don't pull from some applications and you aren't concerned with those. You can just choose to omit those applications from your results and focus on the ones you are actively using in your reports. You can choose to sort the results by either application or by table, and then choose if you want to list only tables that are on, off, or both. Following that, you can also select what types of changes you want to review, whether it be for newly created tables, deleted tables, or even changes made to any of our pre-existing clustered indexes. So now we are going to backtrack a tab and go to the Export Schema tab. As previously mentioned, this routine goes hand in hand with the Compare Schema routine. The Export Schema routine will allow you to do the opposite of the Compare Schema routine and actually generate the XML file and export the schema for your current release. Say you are a facility with multiple rings or HCISs and want to ensure that your schemas match between each ring. Maybe one ring or HCIS is at a different release from another and you want to see the differences between those environment schemas. This routine will allow you to export the schema and then load it into the HCIS at an older release to compare the differences between the two. This is just one example of how the Export Schema routine can be used to your benefit, but feel free to make use of this routine to however you see it to be beneficial to your organization. Now, we're going to head back to the DR main menu where you first enter the Operations desktop. The reason for this is that there are a couple of routines here that are not available within the Operations desktop. One allows you to easily halt your DR transfers manually rather than using the continuous mode downtime schedule that we reviewed earlier on. The other allows you to view non-primary file groups that were created within SQL. To start, from the main menu, go to the Data Transfer option and then go into the Enter Edit Background Job routine. This routine will allow you to set the halt flags for your DR transfers, while the routine beneath it, View Master Transfer Background Status, will allow you to monitor the jobs to ensure they go into a halted status. A few selections down, you will see the View Table File Groups tab. We will start with Data Transfers and come back to show the Table File Groups tab. So let's now go into the Enter Edit Background Job routine to see how to halt the DR transfers. The Enter Edit Background Job routine is an easy way to halt all of your DR transfers. Once in the routine, you will see the DR Master Background Job from the Monitor routine, as well as the DR Transfer job from the Data Transfers routine, that are both found within the Operations desktop, all in one place. To stop the job, just set the DR Master Background switch to off, and then at the bottom, you will see 3 set all fields for hang, trace, and stop. You will want to put a Y in the stop field and then see that all of your transfer jobs will have a Y populated next to the stop field above. After that, just click Save and go back to the View Master Transfer Background Status routine and watch the jobs until they are halted. To restart the jobs, you will simply just reverse this process by setting the DR Master Background switch to on and putting an N in the Set All Stop field and then clicking Save. After that, go back to the View Master Transfer Background Status routine and watch the jobs until they start back up. Should you have any issues or questions about stopping the jobs, then feel free to reach out to your data repository specialist. Now, we'll take a look at the non-primary file groups routine I mentioned briefly a moment ago. .615 Data Repository introduces a significant scalability enhancement by introducing support for multiple SQL file groups. File groups allow your database administrator to separate certain high importance or high volume tables into their own files that are managed independently of one another. This provides more flexibility in performance tuning or designing a backup scheme. This routine allows you to view what file groups the DBA created and the tables contained within them. The View Tables field is a lookup field that allows you to select a file group and see what tables are a part of that file group. Once you choose the file group, any tables placed into that file group will be displayed. For the selected table, you will also see the location of any indexes that were placed on the table. We only show the standard non-clustered index on the screen, but if you or your DBA were to create any non-clustered indexes, they would appear here as well. All right, everyone, that brings us to our halfway point. At this point, I'm going to open up the floor for any which ones have finished. By default, only 3 SILs can be run at any one time. However, this can be adjusted depending on your DR background job machine. If you set up more than the defined limit, you can simply add a priority to your SILs to determine the order in which they will run by simply clicking on the priority button located at the bottom of the screen. If you start an SIL and decide you would like to adjust how many workers are processing the data, then you can just click the Stop button to stop the SIL. Then click on Edit Workers to adjust how many workers you want to process the data, and then click on Restart to resume the SIL from where it left off. Lastly, if you set up an SIL already and want to be able to run it again in the future without having to fill out the criteria again, you can click on the Save as Template button, give the template a name, click Save, and now you have saved your previous SIL as a template. In order to set up an SIL to be run, you just need to click on the New button to open up the SIL template where the configuration will take place. When you first enter the new SIL screen, everything will be blank. In this example, I have already populated everything, but I will now walk you through what you need to populate as well. The first thing you will do is give your SIL a name. This will be what appears in the previous screen, so we recommend naming it something that is recognizable. If you have already created an SIL template, then you can simply hit F9 in the template field, pull in your template, and click Start. Next is the Since Edit Date field. What this will do is allow you to define a date in the past in which the SIL will begin processing from. So if you are concerned that you are missing data from a week ago, then you can just define a date from last week, and that is the only data that the SIL will look at. tables associated to it and the MAT records that are the equivalent to those tables. Next, we have the validation. The premise of the validation is the same as with NPR, where you can compare a SQL table to the data stored in its corresponding MEDITECH structure to be able to audit for data integrity. Both the screen shown here, as well as the Create a New Validation screen, closely resemble the corresponding SIL screen. This is intentionally designed to improve your comfortability with these routines. The same type of information is displayed, such as the validation name, status, start date and time, duration, as well as some of the statistics and the parameters that were defined when setting up the validation. By default, all validations are going to be displayed on the screen regardless of their status. So there are two buttons at the bottom of the screen to both hide completed as well as hide scheduled validation. Also, if you run a validation and would like to save it to run again in the future, just highlight the validation you would like to save and click on the Save as Template button. At this point, just give your template a name and click Save, and you can now pull in the saved template for future validations without having to reconfigure everything from scratch. Let's now move on to creating a new validation by clicking on the New button at the bottom left of the screen. When you first enter the screen, all of the fields are going to be initially blank. Not every field needs to be populated, as you can see, so I am just going to discuss what is present on the screen and what needs to be defined. You will start off by giving your validation a name or by pulling in a previously created template. You then move on to set the date and time in which you would like your validation to begin. Following that, you can define if you want the validation to run just once by leaving the recur frequency field blank, or if you want it to run weekly or monthly. Now, you move on to choosing the tables to validate by defining the application or object fields in the top right. These will pull up a list of tables in the Available Tables section based on the defined criteria. Once the Available Tables section is populated, just check off the tables you would like to validate and hit the Select Tables button. If you know what tables you want to run the validation against, then you can type them into the table field to populate the selected tables list. You can also make use of the Import Tables from Clipboard and Import Tables from File buttons at the bottom to quickly populate the selected tables list. After you have selected your table, you can define the number of workers. The default value for this is 4, so if you are planning to increase this number, then we suggest reviewing the resources on the background job machine where the DR jobs are running to ensure that there are sufficient resources. The other parameters below should be left as default, for we have found these to be the most optimal values. The since edit date will allow you to validate data from a specific date and time to the present day. If you set up a recur frequency, then you will be able to make use of the static and sliding options, which just mean that the since edit date will move ahead based on the recur frequency if sliding, while if it is static, the date will remain the same. Next is the sample size and number to check in sample. These values combined make up the approximate validation coverage. We recommend using 1,000 and 1,000 for these parameters, giving you 100% coverage. downloaded version of the HTML view and just point out which